All right, ready to dive into a big one. We're tackling consciousness today, folks. Specifically, can physics explain it?
Yeah, it's a question that's been puzzling, well, pretty much everyone for a long, long time.
No kidding. And to help us unpack it all, we're turning to theoretical physicist Sean Carroll and his paper, Consciousness and the Laws of Physics. I mean, it sounds almost impossible, right? Can physics even go there?
Well, that's the million-dollar question, isn't it?
Because think about it. Our brains, just the ones we're using right now to have this conversation, they're made up of something like 100 billion neurons.
It's an incredible amount of complexity.
And get this, with 700 trillion synaptic connections. That's like more connections than there are stars in the Milky Way. It's mind-boggling.
Absolutely. And we have this feeling, this very personal, subjective experience of being conscious. And that seems, on the surface at least, a million miles away from the world of particles and forces that physics describes so well.
Totally. I mean, how can you get from something like the feeling of joy when you hear your favorite song to, I don't know, the interaction of subatomic particles?
And that's exactly the challenge Carroll takes on. And what's fascinating is he argues that physics, as we understand it now, is already so well established
Hmm.
that trying to explain consciousness by changing the fundamental laws of physics, it's probably not the way to go.
So no need to rewrite the physics textbooks just yet. But then how does he think we should approach this? If it's not about finding some brand new law of physics to explain consciousness, what's the alternative?
Well, he suggests that instead of looking for a new law of physics to explain consciousness, maybe the answer lies in understanding how the laws we already have play out in incredibly complex systems like our brains.
So it's not about finding a new ingredient. It's about understanding how the ingredients we already have are combined and interacting in ways we haven't even begun to grasp.
That's it. It's about how new layers of complexity and potentially consciousness can emerge from the interactions of simpler parts. And the framework he uses for this is something called effective quantum field theory.
Okay, I have to admit, effective quantum field theory sounds a tad intimidating.
It's a mouthful, for sure, but it's actually pretty intuitive once you wrap your head around it.
All right, I'm all ears. What is that in a nutshell, and how does it relate to something as complex as the human brain?
So imagine the universe is like this giant tapestry, right, with all these intricate threads woven together. Quantum field theory is basically describing the threads of that tapestry.
Okay, so like invisible fields of energy kind of overlapping and vibrating all around us.
Exactly. And it's the vibrations and interactions of these fields that give rise to what we perceive as particles. You know, electrons, quarks, all the stuff that makes up you, me, and everything we see around us. Now, the effective part just means that we're focusing on the aspects of this theory that are most relevant to the scales and energies that we encounter in everyday life.
So we're kind of zooming in on the part of the tapestry that shows, say, the human brain, rather than trying to understand the entire tapestry at once.
Exactly. We focus on the level where we actually experience consciousness.
Okay, I think I'm following the tapestry analogy so far, but how does any of this explain consciousness? I mean, how can something as seemingly inert as these vibrating fields possibly create something as rich and dynamic as our inner experience?
That's a big one. And Carroll acknowledges that there's this seeming explanatory gap between the physical stuff and our first-person experience.
Hmm.
But here's where the concept of weak emergence comes in.
Weak emergence. All right, you've got my attention. Tell me more.
Okay, think about water. We all know what water is. Essential for life.
Good old H2O.
Right. But at its most basic level, water is really just a bunch of H2O molecules.
Right. Two hydrogen atoms bonded to an oxygen atom. Basic chemistry.
But you can't get the properties of water, its wetness, the way it flows, its ability to, dissolve things, just from looking at individual hydrogen oxygen atoms, right?
You're right. It's the interaction, the arrangement of those atoms that makes water what it is. So are you saying that consciousness is like the wetness of the brain?
That's a great way to put it. We call it weak emergence because consciousness, in this view, isn't some totally new thing added to the universe. It's more like a different way of describing the incredibly complex interplay of simpler physical things when they come together in just the right way.
I see where you're going with this. So even if we could map out every single neuron and synapse in the brain, which is, let's be honest, still a long way off, we might need this idea of weak emergence to explain how all that stuff actually produces the feeling of experiencing the world from a first-person perspective.
Exactly. It's like we might need physics to understand the building blocks, but then we need something more to understand the cathedral that gets built from those blocks.
Okay, that's a powerful image. That makes me think, though, if it is all just physics, even super complex physics, shouldn't we theoretically be able to build a conscious robot someday? Or is that where things get really complicated?
That's a question a lot of people are asking these days. Could we, if we crack the code of how those billions and billions of neurons create consciousness, could we replicate it with silicons and circuits instead of cells? Build a machine that can actually think and feel.
Right. It makes you wonder, are we missing a piece of the puzzle here? Does our current understanding of physics need some kind of big upgrade to account for consciousness?
And what's interesting is that Carroll actually addresses that. He dives into the arguments of those who think we need to, like, tweak the laws of physics to make room for consciousness.
Okay, wait, hold on. There are people out there saying we need to adjust those fundamental laws. That's pretty bold.
It is. But they're not just suggesting we change things randomly. They're saying there are specific ways that consciousness might be woven into the fabric of reality, ways that our current physics doesn't quite capture. Carroll highlights two main approaches people take with this.
Two approaches to essentially hack the laws of physics. All right, lay it on me.
So one camp, they focus on the dynamics, like how particles behave at their most fundamental level. They suggest that maybe, just maybe, those mental aspects of consciousness could actually directly influence how particles interact in your brain.
So my thoughts could be like changing the charge of an electron.
Exactly. It's a mind-bending idea, but there's a catch.
There's always a catch.
Right. And this is where that effective quantum field theory we talk about comes in. Because according to those rules, electrons don't just change their charge based on your mood. You know what I mean?
Right, because in the world of physics, my feelings don't really influence electrons. Electrons do their own thing.
Exactly. They follow these strict rules. And as far as we know, those fundamental properties of particles are pretty stable, right? So Carroll argues that trying to fit consciousness into physics by messing with how particles fundamentally work, it might not be the best path forward.
Okay, yeah, makes sense. So approach number one, tinkering with particle behavior, probably off the table. What about that second approach, this whole messing with quantum measurement idea?
All right, now we're getting into some really fascinating territory. We're going deep into the quantum realm. So basically, at the subatomic level, things get kind of fuzzy, right? Like, instead of knowing precisely where a particle is and where it's going, all we have are probabilities.
Ah, so it's like the particle is in this weird blurry state of maybe here, maybe there, until...
Until we actually try to observe it, right?
Yeah.
And that act of observing, that's the quantum measurement. It's like you're forcing the universe to choose one specific state instead of it being this blurry mix of possibilities.
Okay, so we go from maybe to this is where it is right now just by looking at it. It feels like we're almost cheating the system.
It's definitely mind-bending.
Yeah.
But how does this tie back into consciousness? Well, some folks theorize that maybe, just maybe, consciousness itself plays a role in those quantum measurements.
So instead of changing the rules of the game, consciousness might be subtly influencing which possibility becomes reality.
That's a really interesting way to put it. Like, maybe our minds are nudging the dice roll. But, and this is the big but, even if that were true, Carroll argues it still doesn't really tell us what consciousness is. It's like we're pushing the mystery back a step without actually solving it.
It's like saying maybe there's a ghost in the machine messing with the electronics, but we still have no idea what that ghost is, where it came from, or how it interacts with the physical world.
A perfect analogy. We still end up with this big glowing question mark.
Okay, I see the limitations there. This is making me think about something else, though. All this talk about consciousness and physics, it makes me think about those philosophical zombie thought experiments. You know, the ones where we imagine a being that looks and acts exactly like us, but supposedly doesn't have any inner experience.
Yeah, the classic philosophical zombie. It could be right here next to us.
Right, having this conversation.
Exactly. It could tell you about its day, maybe even write a poem or something.
Mm,
But inside,
nothing.
no lights on, no conscious awareness, no subjective feelings at all.
And the whole point of that thought experiment is if we can even imagine a being that's physically identical to us but lacking consciousness, doesn't that suggest that consciousness isn't just physical? If it were, wouldn't a being acting conscious inherently be e-conscious?
Right. You've hit the nail on the head. That's the real head scratcher.
Because if it looks like a duck.
It's got to be a duck, right? But here's where Carroll kind of flips the script. He says that if we really, truly buy into this idea that consciousness is just a product of these physical processes, then those philosophical zombies actually become inconceivable.
Hold on, I think my brain just did a loop-de-loop. Are you saying whether or not we believe in zombies actually says something about what we believe about consciousness itself?
Exactly. Think
Okay.
about it. If you're open to the possibility of zombies, you're basically saying there's something more to consciousness than just the physical stuff.
Huh?
Some extra ingredient, right?
Okay.
Some non-physical essence that physics just can't explain.
Okay, so maybe the zombie fans out there are saying physics is great for explaining how a brain works, but it can't explain what it feels like to have that brain.
That's a great way to put it. But if you're on board with Carroll's view, if you really believe consciousness is just how certain physical systems behave, then you look at a zombie acting exactly like a conscious person.
And you say, well, they're acting conscious, so they must be conscious.
Exactly, exactly. But, of course, we run into this tricky problem of relying on outward behavior as a proxy for inner experience.
Because, I mean, a zombie would probably tell you that they were having subjective experiences too, right?
Exactly. Hey, I'm feeling things too. I'm having experiences. So it becomes kind of a circular argument.
So we're kind of stuck then, or are we?
Well, I think what Carroll is getting at is that the zombie argument, it's a really useful thought experiment. It forces us to really examine our assumptions about consciousness.
So it sounds like we're not going to settle the whole zombie debate today, but that probably wouldn't make for a very satisfying podcast anyway, would it? So where does that leave us? If we're not rewriting the laws of physics, how do we make progress on this whole consciousness thing?
Well, Carroll suggests a two-pronged approach. First, he says we need more progress in neuroscience. We need to keep digging deeper into the brain, figuring out the details of how it works. And second, we need a deeper understanding of complex systems in general.
So it's not that physics has all the answers right now, it's that maybe physics gives us the right questions to ask.
I like that. Maybe instead of searching for a brand new particle or new force, the real key is figuring out how all those trillions and trillions of interactions, all governed by the laws of physics we already have.
How they come together to create the conditions for consciousness to emerge.
Precisely.
Wow. Well, this deep dive has given us a lot to think about.
Definitely.
It seems like what we're learning is that consciousness isn't this magical extra ingredient in the universe. It's more like a different way of understanding what happens when matter is organized in a way that allows for, well, for us to experience the world around us, to be aware.
And isn't that what makes it so fascinating?
It really is. Well, until next time, folks, thanks for joining us for another deep dive.